Okay, we'll start. We were discussing number systems, and last week we were discussing floating point numbers, right? Floating point numbers. So we'll write down now. After that, we have discussed some examples, several examples from floating point number and fixed point numbers. In a new paragraph, write down. New paragraph, write down. Fixed point representation. Fixed point representation has good performance. Has good performance and no need rely on additional hardware or software logic. Additional hardware or software logic. But it has limited range of values to represent. Continue with that, continue. Floating point representation has floating point representation can represent greater range of numbers. But it needs more storage space. Okay, then write down the topic. Coding systems. Write down a topic, coding systems. Right? So coding system means now the computer. We are representing different digits. Digits characters represent as example. If you press letter A keyboard press it will be converted to a kind of a binary number. Now you know what's the binary. Something like this, right? Then that okay, then that value, okay, Santuni, I will repeat the later. I think you could that means okay, I can't understand what you are asking. Now this is a new topic. Coding system is new topic. Now we have discussed up to floating point representation. Okay, right? So this value, this is binary value, right? This binary value again converted to a digital or voltage signal, something like this. Something like this, 1 0 0 0. This signal goes to the CPU, central processing unit, actually control unit, central processing unit. Then central processing unit or the processor program kala diyena. If you get this kind of a voltage signal, you have to display letter A, right? When the computer whatever we are doing, even we are pressing a letter or when you are typing, clicking, whatever it is, it will be converted to kind of a binary number that is having 1s and 0. Then it is converted to a voltage signal, that digital signal. That signal is going to the CPU. CPU or the processor is programmed. Pre-program. Kala diyenne. මේ වගේ signal එකක් આવත් ඔයා කරන්න ඕනේ මෙන්න මේ වැඩේ. Right? Now here it is showing the letter A. Right? This is how it is happening. Then මේ වගේ signal එකක් කිව්වහම, if you take this kind of a signal, I am telling it's letter A. එහෙම කියන්න මොකක් හරි method එකක් තියෙන්න එපා. letter එක මේකයි කියලා මෙන්න මේ signal එක this is letter A කියලා කියන්න, there should be a mechanism, right? So that is done by the coding system. That is done by the coding system. That means when you take the coding system, it has separate value for each letter, symbol or whatever we are doing. අපි කරන හැම එකටම මොකද වෙලා තියෙන්නේ? එක්කෝ හැම එකටම code එකක් තියෙනවා. Right? So there are different coding system. First one is BCD. I will give the notes later. BCD. This is stand for binary coded decimal. This is stand for binary coded decimal, right? So when you take the binary coded decimal of BCD, it has only 4 bits. It has only 4 bits. It can represent values 2 to the power 4, that is 16. When you take BCD, it has a 4 bit. 4 bit means bit can be either 0 or 1. It can be either 0 or 1. So what are 4 bits? 0 0 0 0 0 0 0 1 0. Right? So maximum number of this kind of separate Venus code 2 to the power 4 is 16. 16 codes can be created by using this BCD method. Right? Now you can understand, with this BCD, is it possible as to represent characters of the English alphabet? No, because we have 26 letters, but we have only 16. This is the kind of a first kind of a coding system, but it can represent the numbers up to 9. I will write 0 0 0 4 because 4 bits. Now you know how to convert it to binary. Same thing, like if you take 2 divided by 2, you get 1 0. This is the binary value. This is how we are doing converting into binary, because there are some new students also, right? So 1 0 is the binary value. What you have to do is, in BCD we are representing with 4 bits. ඒක නිසා මොකද කරන්නේ 2 එකට ඉස්සරහින් මෙහා bit එකක් දාලා තමයි මේ value එක ලියලා තියෙන්නේ. So like that I am writing it everything. 3 මෙහෙමයි, 4. Same like the binary. Only thing is you are representing with 4 bits. Right? Only thing is you are representing 4-bit. So this is how BCD is representing values. It can represent all these numbers from 0 to 9. Then you may think, okay, there are 16 symbols that can represent with the BCD. එහෙනම් අනිත් ටිකට මොකද වෙලා තියෙන්නේ කියලා ඔයගොල්ලෝ දැන් කල්පනා කරනවා ඇති. right? අනිත් ටිකට වෙලා තියෙන්නේ other remaining values are representing some commands. Commands තමයි ඒගොල්ලෝ not the data, they are used to represent some commands. ඒගොල්ලෝ BCD is something like this, right? අපි ඒක ලියාගමු. Write down the coding system. Topic is coding system. Under that write down under coding system, characters are represented on computers using several standard methods. Under that, write down the first one, BCD. First one, BCD. Under that, write down BCD stands for binary coded decimal. This is a 4-bit code. Only 4 bits are there. 4 bits code. That can represent 2 to the power 4 equals 16. 2 to the power 4 equals 16 characters. But it can represent numbers from 0 to 9. As follows. Okay, take this down. 0 again. 4 zeros. 1 0 0 1 2 like that. Take it down quickly. Up to 9. Only up to 9 you have the values. Okay, we'll see how to, when you get a decimal number, how to convert it to BC. Right? Write down like this. Convert following decimal numbers to convert following decimal numbers to convert following decimal numbers to BCD numbers. BCD numbers. Okay, first one I will do for you. Now 3, how to represent 0, 0, 1, 1. Right, if you can remember, that's fine. Otherwise, you can divide it by 2 and get the binary, then put 2 zeros and make it to 4 bits. Now here, even it is coming from the beginning. නැත්නම් මුලට 0s එනවා කියලා ඒක අයින් කරන්නේ නැහැ මේකෙදී. 7 you can write. So you can write like this. This is the BCD webinar, right? Okay. Try to do other 3 and send me through the chat. Chat එකට දාන්න. Zoom chat එක හරහා මට එවන්න. Answer again. Try to do other 3. Around 80 students have sent me the answers. Okay, we'll see. 705. So how to represent? 7 you can represent 0, 1, 1, 1. 0 is 4 zeros. 5, 0, 1, 0, 1. 126. 0, 0, 0, 1. 0, 0, 1, 0. 0, 1, 1, 0. 489. 0, 1, 0, 0. 1, 0, 0, 0. 1, 0, 0. So these are the answers. Check your answers. That's easy, right? So I gave you the how to represent the numbers. But next time you have to memorize that, or you can just convert it to binary and put another zeros in front and make it to 4 bits. Right? Now this is how you represent decimal numbers to the BC. Sometimes you are getting BCD numbers and asking for the decimal number. That is also possible, right? Write down like this. Convert following. Convert following. BCD numbers to relevant their decimal values. To their decimal values. Okay, I am showing the first one. From right hand side, you separate each 4 digit. Each 4 digit. Then we know how to convert it to decimal. Binary and decimal kind we have discussed. Method in that 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Again, if you take 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. Now, values 1, 2, 4, 8. I got 1, 2, 4, 8. So, what is the value you are representing with this value? BCD parts, portions. Here you got zeros. Here only you have 1. That means from this portion you are getting the value 1. Make him go there. Means zeros. That means the relevant value is 2. And method 2 gun. Method 1, 2, 4, 8, 8, 12. So you take 8. So your decimal value is 821. So that's how you have to do. Right? Separate each 4 digit and find the value. Find the value from each portion and write them together. Write them together. So binary to decimal kara ne ami 1248 කියලා දෙනවා. I 1248. මෙතන 1 දෙකක් තිබ්බනම් මෙතනත් 1 තිබ්බනම් එන 1 + 2 දෙකක් එකතු වෙලා 3 කියලා හැදෙනවා. දැන් මෙතන එහෙම ඒවා නැහැ. හැම එකක්ම එක ගානේ තියෙනවා. ඒ නිසා ප්‍රශ්නයක් නැහැ. Okay, try to do that and send me the answers for the other 3. I thought the answers for one. දැන් මම මට answer එකක් ආවා. බලමු. Okay, most of you have sent me the answers. Second one, we'll see. Second one, we have to separate each 4 here. And 1, 2, 4, 8. Again, 1, 2, 4, 8. 1, 2, 4, 8. Right? 4, 8. I'm not writing because it's 0. No value is coming. Here you get 3. Here you get 4. Here you get again 2. So 243. 243. Next one. Separate each 4 digit. Now separate. And here you get 1, 2, 4. Here 1, 2, 4. 1, 2, 4, 8. Right? Here you get 3, 4 plus 1, 5. Here 6. 356. Check your answers. The last one. Separate each 4. 1, 2, 4, 8. 8 is there on my exam. 1, 2, 4, 8. 4 plus 2 plus 1, 7. 1, 2, 4, 8. 8 plus 1, 9. So your answer will be 978. Right? I think it's clear with you all. So this is how you are using BCD to decimal. Now suppose you are getting a BCD something like this. And BCD what's the decimal value? So can it be a BCD value? Can it be a BCD value? So I will convert it to decimal. 1, 2, 4, 8. 8 plus 2, 12. So 12 can a number BCD value. We have numbers from 0 to 9 only. You can 12 represent 1 and 2 separately. This is wrong. So the BCD, remember that we can represent numbers from 0 to 9 only. We can't represent any number other than that. Right? Right? Okay. I think BCD is clear with you all. Then we'll go next one. That is called Ascii. Then write down the second one. Now under this coding system, we have discussed BCD. Now second one is Ascii. This is called American Standard Code for Information Interchange. Right? Here you have 7 bits. That means you can represent 2 to the power 7, 128 characters. Now this is ASCII with okay with the most of the computers. Why? Because we can represent 128 characters without any problem. That means we can represent the English alphabet and the other symbols, capital symbol, letters, everything. Right? That is possible. So because of that, ASCII is used in most of the computers. And the other thing is it has a sequential pattern. Sequential pattern. As example, if you take A, capital A, 65. 65 can value binary. Binary means Ascii code maybe. Or no. You make it to 8-bit because, sorry, 7-bit is there, right? 7-bit only 7 bits are there. So 1, 2, 3, 4, 5, 6, 7. 65 is coming like this. Or you can divide by 2. Or divide color, they can right? That's the binary. So we are representing like this. But I told this is sequential. Sequential means what? In 66 when B 67, C ඒ කියන්නේ අපිට එක letter එකක් දුන්නාම සාමාන්‍යයෙන් capital හරි simple හරි උන් දුන්නාම එකක් දුන්නාම we can find out the other letters. As example, if you get C කියලා මම 67 දුන්නොත් ඔයගොල්ලෝ දන්නවා B කියන්නේ 66 A කියන්නේ 65. ඔයගොල්ලන්ට ඊට පස්සේ ඒවට තරපුවා D කියන්නේ නම් 68 E කියන්නේ 69 C D F කියන්නේ then 70 like that you can. So that is called sequential, right? Okay, we'll write down under ASCII. ASCII කියන එක ලියාගන්න. ASCII stands for American Standard Code for information interchange. Only 7 bits are available to store each character. It can represent 2 to the power 7 equal 128 characters. 2 to the power 7 equal 128 characters, different values. This coding system originally proposed by the American National Standard Institute. Originally proposed by the American National Standard Institute. American National Standard Institute. Within bracket put ANSI. 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 American National Standard Institute. This coding system is used by the IBM personal computers. Okay, put example like this. So 65 you can write 66. 67. You can represent like this with the ASCII code. Take them down. Okay, write down like a question. I'll erase this part. Write down like a question. If B is represented, if B B is represented with, write down this one, 1 0 0 0 0 1 0. What is the ASCII code? What is the ASCII code for H? If B is represented like this, what is the ASCII code for H? So, ඔයගොල්ලෝ මේක B එකේ value එක හොයාගෙන decimal value එක හොයාගෙන then equals H එකේ decimal value එක හොයාගෙන then you can convert it to binary by dividing by 2 and get the ASCII code with the 7 bits. Second question, write down. Write down the ASCII code write down the ASCII code to represent following words. Following words. If letter A is represented by, if letter A represented by this one, write down. So what you have to do, you have to first find out the decimal value 1, 2, 4, 8, 16, 32, 64. ඔය විදිහට දාගෙන ඉන්න ඕන. දාගෙන ඇවිල්ලා හොයාගන්න decimal value එක. So you can write down like earlier ඉස්සෙල්ලා මම කියා දීපු වගේ 2 to the power 0 2 to the power 1 වගේ ඒක දිගටම දාගෙන ඉන්න ඕන. අපි ඉස්සෙල්ලා 2 to the power 3 වලින් නතර කරානේ. එහෙම නැතුව ඔක්කොම දාගෙන 2 to the power 4 2 to the power 5 2 to the power 6 කියලා දාන්න. Then you find out the decimal value. If A is that decimal number, I'm not telling, I can't decimal value na. ඔයා බලන්න B එක කීයද? C, because it is sequential. So අපි capital letters දීලා තියෙන. එතකොට යන්න පුළුවන්. ඊළඟ try to find out the answer for cat and bat, these two, and send me the answer through the chat. Send me the answer through the chat. I will help you to do the first one. Some of you have sent me the answers. First one asking H. B is given. B is given. So B is what? 1, 2, 4, 8, 16, 32, 64. 64 plus 2. B is 66. If B is 66, 67, 68, 69, 70, 71, like that, no? C, D, E, F, G, H. 72 is coming for the H. Now what you have to do, I will show you. 72 you can divide by 2 to convert it to binary. So here you get 3, 6. Your remaining value is 0. Here you get 1, 18, 0. 18 divided by 2, 9, 0. 4, 1, 2, 0. 1, 0. From bottom to top, you are writing the value 1, 0, 0, 1, 0, 0, 0. So here you get 7 bits without any problem. 7 bits without any problem. So H is, this is your answer, 1, 2, 3, 4, 5, 6, 7. This is your answer for the first one. Now try to find out cat and bat. Now I have done some help. කරලා තියෙන්නේ සමහර අයවල තියෙනවා මේ දෙකත් වචන දෙකත් හදලා ඒවල තියෙනවා some of you Tisagi Ilan Umetra Kaviru Tisas. Okay, try to do that quickly. I will take cat. What do we have to do? Now we have find. C is what? 67. A is, so 66 will be B and 65 will be A. Like that you can find out T also. T is coming 84. I think it is 84. Okay, right? So like this way you can find out. Then to divide by 2, each letter. A is there, C is there, A is there, D is. So if you write it properly, that means in a correct manner, C is 67, right? 67, you can write 1000. We'll take this one, right? So this is C. And A 100001. And T 84. 64 you had to add 16, 80, something like this. Then write them together. So I can write, I'll write from here 1000, 101, 1000, 001, 101, 0100. This is equal to, this is how you have to write the answer. Then find out that also. C is, there's a small mistake. +64 2 + 1. 67 is CS, right? So I'll change it. I think now it's okay. '84. CAT. Find out the other one also bad. So BAD, bad. First to find out the values. B 66, A 65, B 68. Then convert it to binary. Then it will be easy. B 66, A 65, D 68, then write them together. Now if you can't write it at once, එකපාරට ලියාගන්න බැරි ඇති. ඒකට ඔයගොල්ලෝ අර විදිහට බෙදලා ගන්න. It doesn't matter. Right? So I can write down say 1 0 0 0 0 1 0 1 0 0 0 0 0 1 1 0 0 0 1 0 0. This is your ASCII code for bad. So any word you can find out like this without any problem. Check your answers. Okay, I think you're okay with that one. Then write down the third one. Third coding system. That is EBCDIC. EBCDIC. EBCDIC, extended binary coded decimal interchange code. I will tell you now. This is used 8 bits. That means it can represent 2 to the power 8, 256 characters. 256 character. 256 can represent Kanpura. Right? Now this coding system was used in mainframe computers, IBM mainframe computers, mainframe mini computers we have discussed in unit 1 and 2. AI computers right? Okay, we'll write down. EBCDIC stands for EBCDIC stands for EBCDIC stands for extended binary coded decimal interchange code. Decimal interchange code. It has 8 bits. It has 8 bits. That means it can represent 2 to the power 8 equal 256 characters. 2 to the power 8 equal 256 characters. This coding system was used in IBM mainframe computers and compatible equipment Okay, so that's another coding system. Nowadays we are using that. අපි දැන් පාවිච්චි කරන්නේ මෙන්න මෙහෙම එකක්. Unicode, universal code. Unicode stands for universal code. Here you have 16 bits. That means to the power 16, 65,536 characters. ඔන්න දැන් ඔයගොල්ලන් කල්පනා කරනවා ඇති characters ගොඩක් ප්‍රමාණයක් ලොකු ප්‍රමාණයක් we can represent. So that's why nowadays computer we can type different characters. අපිට සිංහල letters type කරන්න පුළුවන්, English type කරන්න පුළුවන්, Japanese, whatever language we can type. So why? Because we have Unicodes. That means you can represent 65,536 characters, different characters. ඉස්සෙල්ලා අපිට ඔක බැරි උනේ මොකද? අපිට තිබ්බේ characters ගාන limited. As example, if you take BCD 1 කියන එකට 1 to 9 අපි හිතමු ASCII එකට අපි ගත්තා 65 ගන්නේ. දැන් මං අයන්න අකුරක් නැත්තම් දෙමළ මොනවා හරි අකුරු කරන්නත් 65ම දාගත්තොත් මොකද වෙන්නේ? Right? So what will happen? When it goes to the processor එකට ගියාම එයා කල්පනා කරනවා මම පෙන්නන්න ඕනේ ඒද අයන්නද Tamil වලින් අයන්නද මොකක්ද කියලා හිතා ගන්න බෑ. ඒක නිසා මේ හැම letter එකකටම හැම symbol එකකටම we need to have separate character. අපිට අනිවාර්යයෙන්ම separate character එකක් ඕනේ. But with the ASCII EBCDIC we couldn't do that. Why? It is not enough. 127යි 256යි 9යි sorry මේ 16යි ඉස්සර තිබ්බ BCD. එතකොට අපිට වෙන එක letter වලට වෙනම code එකක් දෙන්න බැරි වුණා. That's why we couldn't represent any characters earlier. But nowadays what has happened? දැන් මොකද වෙලා තියෙන්නේ? අපි example එකක් ගත්තොත් මම මේ example එක ලියන්නේ. මට දෙන්න පුළුවන් 250 විතර අයන්න. 300 විතර මේ දෙමළ අකුරු වලට. ඒ හරිය මොනවා හරි මම මේ නිකන් කිව්වේ. මම දන්නේ ඇත්තටම මොකද්ද කියලා මේක. It can be changed even according to the different font type එක change වෙන්න පුළුවන්. හැබැයි හැම එකටම we are getting separate value, different value. That's why එතකොට මේකට එන signal එක නෙමෙයි මේකට යන්නේ. First at the very first at the beginning I show you how this is happening. It is converted to a electric signal. එහෙම අපි කතා කරන්නේ. එතකොට මේක එන signal එක නෙමෙයි මේකේ. මේ signal එක නෙමෙයි මේකේ. Then processor is predefined. මේ signal එක ආවම ඔයා මේක පෙන්නන. ඒක ඇත්තටම map කරන්නේ අපි මේ font එකත් එක්ක map කරන තමයි coding system අපි use කරන්නේ. This mapping අපි font එකක් install කරනවා කියලා කරන්නේ. We are installing font, Sinhala font එකක්. If you can't type in Sinhala in your computer, you are taking a font and you are installing whatever it is. By installing it, what will happen? It will tell processor, okay, these are the characters in this alphabet or the character related values for these different characters. එයා කියලා තියෙනවා map කරලා තියෙනවා processor එකට කියනවා මේ 250 මෙන්න මේක තමයි signal එක ආයන්නේ. එතකොට processor එක දාන්නවා මේක ආවම මම මේක ආයන්නේ කියන එකයි type කරලා පෙන්නන්න ඕනේ. So that is called Unicode. Unicode, under that write down. Unicode stands for Universal Code. Unicode stands for Universal Code. It has 16 bits. It has 16 bits. Where you can represent 2 to the power 16 equal 65,536 characters. 65,536 characters. Unicode is used to represent many of the world's languages, including Sinhala and Tamil. Right? Now these are the coding system. Then write down in a new paragraph. Advantages and disadvantages. Of different coding systems. Are given below. මේ විදිහට table එකක් දාගන්න මේ විදිහට දාගන්න advantages and disadvantages. This side you put a coding system. Right. First thing we are going to discuss about BCD. Take it down first. Then don't draw this line because sometimes you may like not enough space, so you have to draw it again. So after finishing this only, you put the bottom line. Bottom line. So BCD, will take the BCD first. Advantages easy to encode and decode. Decimal into BCD and other side, or vice versa. Easy to encode and decode. Decimal into BCD and vice versa. Right? So it is easy to encode and decode decimals into BCD and BCD into decimal. That is one advantage. We take another advantage under BCD. simple to implement. Simple to implement. Hardware algorithm. Hardware algorithm. For the BCD converter. For the BCD converter. Right. So that means if you take the digital watch, values ටික හැදිලා තියෙන්නේ. ඒ කියන්නේ මේ lights ටික set වෙලා තියෙන්නේ. හරි I will show you I will give you a small question later. එතකොට මෙන්න මේ වගේ එකකින් තමයි BCD එක හැදිලා තියෙන්නේ. Right? මේ each one has a value. අපි දැන් මේක 0 1 2 මේක 3 4 5 6 ඔහොම values ටිකක් එකතු වෙලා තමයි හැදෙන්නේ. අපිට ඕන වුණොත් if you want to show letter not the letter number 3 වගේ පෙන්නන්න ඕනත් අපි මෙන්න මේ ටිකනේ පෙන්නන්න ඕනේ. ඔහොමනේ පෙන්නන්නේ. So only these circuits or lights are working. So අපිට value එක පෙන්නන්න. I will give you a small question and then you can understand this better, right? So this is easy. That's why we can implement circuits implement කරද්දි BCD නිසා that is easy to implement, right? Especially numbers. මේක numbers එක තමයි deal with, right? Then write down the disadvantage. Disadvantage පොඩ්ඩක් දාගමු. One disadvantage write down, not space. The space is not efficient or enough. Write down. Space is not efficient. One is disadvantage. Another one write down. Difficult to represent. Difficult to represent. Difficult to represent. Represent the BCD form. BCD form. BCD. In high-speed digital computers. In high-speed digital computers. Okay, then write down. Okay, that's all for the BCD. Then write down Ascii coding system. එක දාගන්න Ascii. Coding system is Ascii. Next one Ascii. There under that write down advantages. Advantages. Use a linear ordering of letters. Uses a linear ordering of letters. linear ordering of letters. Another advantage, compatible with modern encodings. Compatible with modern encodings. Compatible with modern encodings. Another one, write down. Another advantage. Different versions are mostly compatible. Different versions are mostly compatible. Different versions are mostly compatible. Then write down some disadvantage side. Disadvantage. Not standardized. Not standardized. Not standardized. Another one, another disadvantage. Cannot represent world language. Cannot represent world's language. Then write down EBCDIC. Third coding system, EBCDIC. There write down advantage. Use 8 bits, and it is more extended than the ASCII, so you can represent more characters. Use 8 bits. Use 8 bits. So it contains more characters than ASCII. So it can contain more characteristics. More characters than ASCII. More characters than ASCII. They are write down a disadvantage side. Disadvantage does not use a linear ordering of letters. Linear නෑ. ඒතොර A කියලා දැනගත්තාම we can't find out B. ඒක something else. ඒක linear නෑ කියන්නේ ඒකයි. Now Ascii is linear because A 65 and B 66 කියලා අපි දන්නවා. හැබැයි A කාරකේ වෙන අගුණන්න අගයක් නම් we can't find the B because it is not linear. B කියන්නේ වෙන සම්පූර්ණයෙන්ම වෙනස් value එකක් වෙන්න පුළුවන්, right? They write down disadvantage does not use a linear ordering of letters. Does not use a linear ordering of letters. Another disadvantage, not compatible with modern encodings. Not compatible with modern encodings. Modern encodings. Then go to next coding system, Unicode. 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 There, write down. There, write down under advantages. Under advantages, standardized. This is standardized. That means it is standard that you can represent most of the characters. Standardized. Another advantage, can represent most written language in the world. Can represent most written language in the world. Can represent most written language in the world. Then write down some disadvantage. Disadvantage, need twice memory. Memory එක ගොඩක් ඕනේ because it is 2 to the power 16 ලොකු bit ප්‍රමාණයක් තියාගෙන ඉන්නේ, right? Need twice memory to store ASCII characters. ASCII characters. We in the ASCII we have only 7 bits or 8 bits. 7 bits only, but this is twice time 16 දෙගුණ කරත් වැඩි. Need more space to store the ASCII characters. Need twice memory to store the ASCII characters. Okay, I'm going to give you a small question. That is not in the T1. Write down like this. This is like a question. This is a question. Write down like this. 2 7 segments. 2 7 segments. 2 7 segments. Displays are displays are 2 7 segments. 7 segment displays are used on a car dashboard. Displays are used on car dashboard. Used on the car dashboard to give information. To give information to the driver. To the driver. Each segment is numbered. Each segment is numbered as follows. Now you can see two segments are there to give the information. Now this is actually BCD are using this kind of thing. So 1 2 3 4 5 6 and 7. So these are the numbers starting from 1 7 right? So that means that's another segment. Segment from this segment you can see this is kind of a I make a P, right? So look at here. For example, the information 1P shown above is represented by එතකොට මේ 1 කියන එකයි 1 කියන එක හැදිලා තියෙන්නේ 6 කියන part එකයි and 3. Then P is connected with 5 6 1 2 7, that right? So if you take 1 mean the 1P කියන එක 1 කියන එක ගත්තොත් what are the values? 2 එක තියෙනවා 3 එක, right? So in your register 0 1 2 3 4 like that you are getting. So 1 and 2 are 1 මේ දෙක 1 අනිත් ඒවා 0. That means it is showing the value 1 here. මෙන්න මේ light දෙක පත්තු වෙන්නේ. It is working when the registers value are coming like this. එතකොට P එක හැදිලා තියෙන්නේ කොහොමද? P එක හැදිලා තියෙන්නේ මෙන්න මේකේ. P එක හැදෙන්න you need to have 1 here, 1 is there, 2, then again 7, here 7, here 6, then you have 5. On OTK you can see these values may 7 එක 1 වෙලා තියෙනවා 6 එක 1 වෙනවා. So these are becoming 1, right? Others are 0. Then your lights working like a letter P. No, my head, right? So I think you could understand that, right? So I need you to find out the displayed from this part. මේකේ මොකද්ද පෙන්වන්නේ කියලා මට ලියලා පෙන්නන්න. First you take this down. මේක ටික දාගන්න. Otherwise can't understand. මේ part එක, this is the example part. You have to take it down. Then tell me and send me the answer through the chat. What is the value you are getting from this part? Value in the sense letter. මොකද්ද making it දෙන letter එක කියලා කියන්නේ. Okay, Mandira has sent me the answer. Correct. Very good. Okay, try them out quickly. Okay, Raviru also has sent me the correct answer. Okay, Tisas also has sent me the correct answer. Asante, check it again. Okay, then you'll have send me the answers. Okay, right? So I'm going to show that. I drew it here. I don't know if they see it properly. So here you get 1100, 1100. That means you are coloring the values, that is 2, 3, 6 and 7. So when you color 2, 3, 6 and 7, you get 4. 4 කියන එක තමයි එන්නේ. දැන් මේක මෙහෙම ලිව්වට මේක display කරන්නේ මෙහෙම. කියන්නේ මේ with the lights. Then other one 1 is there, then 5, 6 and 7. 5, 6 and 7. That means you get F. Right? So this is how it represents 4F like this. Right? I think you can understand that. So we are going to discuss this kind of things, how we can use this number system, scoring system practically, especially number system practically to represent something, right? So I am going to discuss some question related to that part on next week. Plus we have some more to cover, like shift keys, that means shifting values, then XO, no, those stuff that it is included in the tutor also. These questions are not in that tutor, right? So most probably you can finish this lesson and try to collect that tutor, that is past paper question plus unit test. Don't open that unit test now. If you have collected that envelope, don't open it until I tell you. open කරන්න එපා. ඒක අපි ගිය පාර වගේ දෙනවා ටෙස්ට් එකක් විදිහට දීලා we are recording that marks in your file. ඒතර ෆයිල් එක හම්බෙලා නැති අය එහෙම ඉන්නවනම් just send me a message, personal message එකක් දාන්න, WhatsApp message එකක්, then I will keep them at the Samadhi Institute, right? Okay, then we'll finish for the day. So we'll meet on next week. Thank you and have a nice day.